And I'm making this video today to tell you about a wonderful opportunity you have to invest in yourself and your own future career goals by enrolling in Matthews Tutors. I'm currently a freshman student at Columbia University in the city of New York, an Ivy League institution, where I am studying neuroscience and behavior on the pre-med track. I personally don't believe that I would have had the ability to call myself a Columbia student had it not been for the efforts of Matthews Tutors all those years ago. When I was in high school, I struggled with math, and I knew that I struggled with math. Math filled me with fear, and I wasn't confident doing it. But after just a few sessions with Matthews Tutors, not only was I instilled with the confidence to go forth in whatever math classes I chose to take, but I was able to increase my ACT score by almost 10 points, helping me earn a super score of 35. With those numbers, I was able to get accepted to all 16 colleges I applied to, including, but not limited to, Cornell University, Georgetown University, Tulane University, Duke University, and the college I currently attend, Columbia University. Matthews Tutors is going to do everything that they can to help you. That's what they did for me. But not only are they going to help you be a better student, they're going to continuously check in on you. I know that I personally received a lot of messages of support from them during my first semester of college, which was one of the hardest semesters I've ever experienced as a student. Matthews made sure that I had the confidence to go forth and pursue my own academic goals, but they also helped me increase the numbers too so that I could get where I wanted to be. And I know that they can do the same thing for you if you give them a chance. Thank you.
Good afternoon, everyone. Thank you for joining us today. I hope you've had a good week so far and you're getting ready for school. I'm sure some of you are getting ready to end the summer and start preparing for the upcoming school year. So we're here to help you out with your math. Today we're going to focus on 8th graders to 12th graders. We're going to have lots of different topics that we're going to walk through. And today I decided to bring in some SAT questions and ACT questions that we can walk through together. And so I look forward to enjoying this hour with you all. And also remember, feel free to ask as many questions as you want. If there are topics that are of interest to you that we're not talking about here, please let me know and we'll make sure to create some time to add those topics to our list of topics. So go ahead and subscribe if you're not already a subscriber to the channel. And also give us a like on this video. We'll get started in a few minutes. We're just going to wait for 1 or 2 more students to join us and then we can get started. What I've also done today is make sure that for each of the questions I'm giving you an idea of the topic that is relevant and also the grade level. And here, I know we're talking about high school, so the grade is not as important, but I'm telling you, if it's Algebra 1, if it's Geometry, Algebra 2, And there's a topic here that is most likely for 8th graders and under, so I also indicate that for you. All right. So thank you all for those that have joined. If you are new to our session, the way our session is going to go is that I'm going to put the question up there, and then you get a chance to answer, and then we'll walk through it together as a group. And then if there are questions that you have as a result of our process, I like to use the process-driven approach, so I don't skip any steps. I want you to understand all the steps that are required to answer this question so that you can do them on your own. And so that's what we're going to do. Once we're done with each question, then we'll have 2 puzzles. I think after about the 3rd or 4th question, we're going to have a puzzle, and then we'll have a puzzle to end the session. All right, so let's go ahead and get started with the first topic. The first topic I'm going to put here because last week we had some difficulty with this topic, and it just came up as a result of solving fractions. So I thought we'll give this an opportunity for us to walk through it together. And so give this a try and let me know what you come up with as your answer, and then we'll walk through it together. I don't want you to feel that because you are not in 6th grade or 8th grade or 7th grade that you can't answer this question. Whenever I bring questions like this, it's an opportunity for you to review something that you may have learned in the past. So go ahead and give this a try. Let's walk through it together. It's going to be a fun experience. Hello, how are you? Thank you for joining us today. So we're going to be looking at the LCM of 3 numbers, least common multiple. And when you're dealing with fractions, it's called least common denominator. So this is a very important topic, and I want to make sure that I show you how to address this topic. I see someone has an answer of 2. Least common multiple. And that's the reason why I'm bringing this up, because sometimes students mistake the multiple and the factor. So we're looking for the least common multiple. Multiple is a multiplier, factor is a divider. If you're not sure what to do, just say I'm not sure, and then we can just get in and try to solve this together. Also, if you have questions, maybe as you're walking through it, you have some questions about your process, feel free to leave them in the chat. I will go to the chat to take a look at. I'll go back and forth and check, make sure that I'm addressing your concerns, your questions, or even your suggestions. I'll make sure that those are addressed. Okay, looks like let's give maybe 30 more seconds. You guys feel like you need more time, or you're not even sure what to do with this? Okay, let's go ahead and solve this question together. There are 2 methods for identifying the LCM. One of them is listing the multiples. I don't like that method, especially when we have large numbers. It takes forever to get to the answer. So what we're going to do, the method I'm going to use in this case is going to be the factor tree method. We're going to write each number in terms of its prime factors. So let's go ahead and do that. We're going to draw a factor tree for each of these numbers and see where that leads us. So let's go ahead with 24. So we're looking only at prime factors. So I'm going to use 2 and 12. So you can see that this right here has to be on the left hand side of the tree, you have to always have prime numbers. And then we divide. And for those who don't remember what a prime number is a number that has 2 factors, 1 and itself. And also remember, 1 is not a prime number because it has only 1 factor. So let's go ahead. 12 we divide by 2, and then we have 6. 6 we divide by 2, and then we have 3. So now 24 is going to be 2 to the power of 3, because there are 3 instances of 2 right here. That's what we're going for. 2 to the power of 3 multiplied by 3. And then let's go for 60. 60 we're going to divide by 2 because it's an even number. We get 30. We divide 30 by 2. We get 15. And then 15 we divide by 3 and we get 5. So we have 60 is equal to 2 to the power of 2 multiplied by 3 multiplied by 5. Now let's go for 96. 96, even number, we divide by 2 and we get 48. 48 we divide by 2, we get 24. 24 we divide by 2, we get 12. 12 we divide by 2, we get 6. And then 6 we divide by 2, we get 3. So 96 is going to be, let's count how many instances of 2. Remember, you're going to always go this way and end right here. So 1, 2, 3, 4, 5. There are 5 instances of 2. So 2 to the power of 5 multiplied by 3. So this is how you will go about this. The first step, remember, is to express each of these numbers in terms of their prime factors. Now the next step is we're going to identify the LCM. How are we going to do that? What you're going to do with the LCM, this is a very important point. We're going to identify all the unique factors, all the unique prime factors that show up for every single number. So let's look at 24. We have 2. We also have 3. For 60, we have 2, 3, and 5. We already have 2 and 3. So I'm just going to put a 5 here. And for 96, we have 2 and 3 as the base factors. Now what we're going to do is, you can see that some of these numbers have exponents. So what we're going to look for is the largest exponent on each of these base numbers. So you can see here we have 2 to the power of 3, 2 to the power of 2, 2 to the power of 5. We're going to use the largest exponent, which is 2 to the power of 5. So now that we have, and look at 3, we have all of them are 3 to the power of 1, 3 to the power of 1, 3 to the power of 1, and then 5 to the power of 1. Whenever you don't have an exponent, you can safely say that the exponent is 1. So now that you have all of these numbers, you're going to now multiply this. You're going to see that 2 to the power of 5 is 32 multiplied by 3 multiplied by 5. 32 multiplied by 3, that's 96. 96 multiplied by 5, we have 0 here, we bring 3 up here, 45, 48. So this is going to be 480 as the LCM of these 3 numbers. So if you look at it, there isn't a number smaller than 480 that you can divide each of these numbers without a remainder. That is the important thing about the LCM. It has to be without a remainder. So this is the technique that I would tell you is the most reliable technique to use whenever you're working through LCM. Are there any questions? So Esther, good job on that. So those who selected 2, I think I understand what you did. You chose the least common factor, not the least common multiple. So I want you to pay attention to that difference. Okay, and for 12, I think you selected your greatest common factor, not your least common multiple. Okay, does anyone have any questions before we go to the next question? Everyone feel good about this? As an overview, let me list some steps for you. First thing you want to do is you want to identify or create factor trees. You want to create factor trees for each number. And you're going to focus on prime factors only. Prime factors only. And then the second one is select unique prime factors. And then finally, you're going to identify largest exponent largest exponent of each factor. And then you're going to multiply them, each factor, and then you multiply them together. So you're going to identify the largest exponent of each factor and then multiply the numbers together. That's all you need to do. All right, let's go to the next question. This actually came from a student. So we're looking at this is going to be system of equations. I want us to see if we can try to answer this. We're looking for the ordered pair, which means the x and y values that make this system of equations true. So we have y equal to 2x plus 4, x minus y equal to -1. So we're going to walk through system of equations. This is an SAT question. The previous question actually was also something I saw on an ACT exam. So you're going to see a lot of what we do today will have some SAT component and some ACT component as well. And also your classwork. So Algebra 1, Geometry, Algebra 2 is about where we're going to be about for today's session. So let's look at this ordered pair. We want to try to solve this. If you're not sure what to do, just feel free to say that you're not sure, and then we'll get into it. Also, if you're joining us for the first time, go ahead and subscribe to the channel. Give this video a like, share with some of your friends who may be looking for a place to come learn. And I want to assure you that this is a place where you can learn safely, you can ask questions, and don't feel any need to always be correct, because we're all here to learn together. So not sure. So I see x equal to 1 for an answer. What about the value of y? Let's look for that. So we need, because we're looking for an ordered pair, it means we need to have an x value and a y value. So I see x equal to, I think that's -3, okay. So we'll give you some more time to just come up with some more answers, and then we'll walk through these problems together, or this specific problem together. Okay, so I see -3, -2. Okay, we have an answer. So let's go ahead and see if we can get to the answer. I'll show you the simplest steps to take for you to get to the answer. So I see a few not sure, so I'm going to go ahead and show you what to do. So here's what we're looking for. When you're dealing with system of equations, there are two methods you could apply. One of them is substitution, and then the other method is elimination. Now, in order for you to decide which of these you're going to use, let's look at the question. We have, let me write this down. So we have y equal to 2x plus 4, and then we have x minus y equal to -1. So these are the two equations that we have. This is the system. We need to figure out which of these methods we're going to use, substitution or elimination. So here's what I want you to think about before deciding on the method you're going to use. Look at this right here. This equation here already tells you an equation that represents y. So if you look at this other equation right here, you have x minus y. So because I already know what the value of y is, all I'm going to do is I'm going to use substitution. It's a lot easier to work with in this case. So we're going to use substitution, and here's what that means. I'm going to have x minus, instead of y, I'm going to replace it with 2x plus 4. And then that's going to be equal to -1. So that's the first step. We're using substitution. Let's make note of that. We're using substitution. Okay, now that we have this, I want you to always remember that whenever there isn't a number before the parentheses, safely put a 1 just for your own understanding and for your own process. So here we're going to have x minus, and now we're going to distribute the -1 into the parentheses. So -1 multiplied by 2x is negative 2x. Negative 1 multiplied by 4 is negative 4. And this is going to be equal to negative 1. Okay, so now we're going to simplify. This is, we call it collect like terms, or we say group common terms. So x minus 2x is going to give us negative x, and then minus 4 equal to negative 1. So now we're going to isolate x. Whenever you're solving for a variable, you're isolating the variable, which simply means the variable stays on its own on one side of the equation. So now we're going to add 4 to both sides. Let's add 4 to both sides. And whenever you have an equal to sign, simply means that whatever you do on one side, you must also do on the other side. Okay, so now we have this. We have negative 4 plus 4 is 0. So let's go ahead and cross that out as something that becomes 0. And then we will continue by saying this is negative x equal to 3. Now remember, I said we need to isolate x. So the coefficient, or the number to the left of x, has to be 1. Here it is negative 1. So we're going to divide by negative 1 to get 1. And then we're going to divide this by negative 1. So negative x divided by negative 1 is going to give you x. And then 3 divided by negative 1 is going to give you negative 3. So x is equal to negative 3. Now the next thing we're going to do is we need to find the value of y. Look at this is our special equation right here. Our x, y pair. So we have negative 3, negative 2. So good job to all. I see a lot of negative 3 answers for x. So this is all you really need to do for this type of question. Ideally, when you practice this a few times, it won't take you this long, but I'm just trying to show you all the steps that you need to follow to get to the answer. For those who did not understand, does it make more sense now? Do you think you can do this on your own? I'll wait for a few responses. If you feel like you need another example, let me know. But if this makes a lot of sense to you, let me know as well, and then we can. Okay. Okay, I can address your question later. It looks like I see you want another. All right, let's go for another one. Okay, let's do another one. One more example. Okay, so let's go for this. Let's go with 3x plus 2y equal to 11. And we have x equal to y minus 3. Okay, so that's our equation. We have our system right now. And I'm giving you a question similar to the one we just did. So I'm not sure what the answers are. I just made it up on the spot. So let's see where that takes us. We're going to follow the process and see where it takes us. We need to find the values of x and y. So the first question you need to ask yourself is, what method am I going to use? I have two methods. I can have substitution as a method. And then the other method I can have is elimination. Okay. So in order for you to determine whether you're going to use substitution or elimination, you ask yourself, is there any equation that is so direct that I can substitute into the second equation? So when we look at these two, we have 3x plus 2y is equal to 11, x equal to y minus 3. I can already see that this is a good candidate for substitution because I have the value of x. So now what I'm going to do is I'm going to replace. So let's go to the next step. The next step here is I'm going to take my x equal to y minus 3 and replace it with the x right here. So 3x, remember, is the same as 3 multiplied by x. So what I'm going to do here is 3, and then instead of x, I'm going to replace it with y minus 3 plus 2y equal to 11. So now we can simplify. We're going to distribute this 3 into the parentheses, into the terms in the parentheses. So this is going to be 3 multiplied by y, which is 3y. 3 multiplied by negative 3, that's negative 9, plus 2y equal to 11. So now we have to group common terms together. So we have 3y plus 2y minus 9 equal to 11. So we simplified 3y plus 2y. That is 5y minus 9 equal to 11. Now we need to isolate the variable. The variable we need to isolate here is y. So that simply means I need to do everything possible to make sure that y is by itself on one side of the equation. So what do I need to do? I need to move the negative 9 away from there. So the opposite of negative 9 is positive 9. So that means I'm going to add 9 to both sides of the equation. So 5y is equal to 20. So let's go with this. 5y is equal to 20. I need to find out the value of y. And remember, whenever you're dealing with equations, you're always doing the opposite. So I'm multiplying y by 5. So I'm going to divide everything by 5 because the opposite of multiplying by 5 is dividing by 5. So we're going to do that right here and right here. So we have y equal to 4. So now we know that x is equal to y minus 3. So x is simply going to be 4 minus 3, which is going to give us 1. And we need to write our answer in this form x, y. So we're just going to say our x is 1, y is 4. So that is going to be our solution set for this system of equations. Are we all good with that? Oh, very good, very good. I see you all like, okay. So you feel like you're better, you understand this better now? Exactly. That is fantastic. So now that we've done that, let's go to one more question and then I'm going to give us a puzzle to work with so that we can just relax. You know, I'm sure sometimes you may feel math can be overwhelming, but it really isn't. So here we're going to some algebra 2. This is composing functions, or you can say composition of functions. So what we're going to do is f of x is equal to x minus 1 over x and g of x equal to 1 over x. What is the value of f of g of 1/2? This I actually got from a past ACT exam. So, but the topic here is composing functions. Composing function. If you're not sure, if you've never seen this before, let me know. It's actually not that complicated, but I'll show you what to do. So what is the value of f of g of 1/2? If you're not sure what to do, also let me know. And then we can just go through it. I'll show you all the different things you need to pay attention to. Okay, so someone is not sure what to do, so that tells me that I need to spend some time explaining what is happening here. Okay, that's fine. Never seen it before. All right. Okay, so it looks like this is something that a lot of people have not seen before. So let's go ahead and answer this together. So for those of you that are thinking of the ACT, this is a type of question you may see on that exam. So I want you to pay some close attention to what I'm going to do here. So what we're looking at here is we have two functions, but we want to find, this is what we call a composition of functions right here. So we're trying to find f of g of 1/2. The way I look at this is I look at my PEMDAS. PEMDAS says parentheses first. So I have a big parenthesis here. So I'm going to find out the value of g of 1/2. I'm going to do that first. And then when I'm done with that, I'm going to find out the value of f of the value of g of 1/2. So let's go ahead and show what that means. So g of x is equal to 1 over x. So g of 1/2 simply means that for every place I find x, I'm going to replace it with 1/2. So this is going to be 1 over 1/2. So we're going to divide. So what is 1 divided by 1/2? 1 divided by 1/2, let's go and do our work right here. 1 divided by 1/2. So this is 1 over 1. And then we're going to change this to a multiplication, and then the numerator and denominator switch positions. 2 over 1, which is equal to 2. So g of 1/2 is equal to 2. So now you can see here that we can replace all of this with 2. So now we're going to find f of 2. which is equal to 2 minus 1 over 2. So now we have all of these. So I'm going to put this here. So there's this method I like to use sometimes if I'm not, if I want to get through this quickly. You have two methods you can follow. One method I like to use, I call this the bow tie method. So here's what I'm going to do. I'm going to multiply the denominator here by the numerator here, and I'm going to multiply the denominator here by the numerator here, and multiply both denominators together. So here's what that's going to give me. 2 multiplied by 2 minus 1 multiplied by 1. So let's say 1 multiplied by 1 divided by 1 multiplied by 2. So this is going to be 4 minus 1 over 2, which is equal to 3 over 2. So in order for you to determine how you express your answer, you need to look at the answer choices. Most of the time on the ACT or the SAT, you're going to end up with an answer like this. But for schoolwork, you can go the extra step and convert this to a mixed number. And that's simply doing this. 3 divided by 2. So we have, how many groups of 2 in 3? We have 1. 1 multiplied by 2, we have 2. We subtract and we have a remainder of 1. So I'm going to make a trip around the wall right there. So it's going to be, this is going to be 1 is our whole number, which is right here. Our remainder is up here and our divisor is down here. So these are the two different ways you can represent your answer. So let's walk through it again. We're going to look at the inside of the parenthesis. We're going to look at the function inside the parenthesis first and try to solve that. So look at the function inside the parenthesis first, solve that. Whatever you get for that function, you're going to apply it to the function on the outside. So does anyone understand this? Does this make sense to you all? Is this clear? You guys get it? Anybody not sure? If you actually want us to do another example, let me know. But let's go ahead and do a puzzle first, and then we'll come back to anyone who needs additional examples on this. Okay. So this is going to be our first puzzle for today. This is called a magic triangle. Anyone know what the magic triangle is? Well, if you know what the magic triangle is, this should be pretty easy for you. So we need to find the values of A and B. Okay, we'll get to one. We'll get to one more example of the previous one after we're done with this puzzle. Also, I just want to remind you all, and I did mention this on Tuesday with the lower grades. I have a new website where you can actually, it's a form. It's the form. I want you to be able to go there and post questions, topics. And if you have a question that you're interested in, take a picture of it and upload the picture, and we can actually use that question for the next live session. Or if there's a topic that you're interested in, go ahead and post that topic. Let me know what topic you're interested in, and then I can bring some questions that would help you better understand the topic. So I'm going to post the link so that you can see that and use that before the session, so I can actually use that in my preparation for topics or questions that we'll be addressing during the session. B is 2 and I see B is 2, I see B is 25, A is 15, I see B is 2 and A is 4. Huh. That is very interesting. I like that. B is 2, A is 4. Okay. All right, that's good. Good stuff. You all are doing so well. B is 2, A is 4. Okay. So here's what a magic triangle is about. I said we got quite a few answers already. I got B is 10, A is 8. So whenever you have, this magic triangle, for the sake of this puzzle, The sides, you have to find numbers that make this all of the sides the same length. Okay, that's what a magic triangle is. In our world of triangles, we can call it an isosceles, we can call it an equilateral triangle, right? So we have 5 plus 4 plus 3, that's going to give us 9 plus 3, that is 12. So that means this must be 12, this also must be 12. So 5 plus 5 is 10, 10, and then this is going to be 2. 5 plus 3 is 8, A is going to be 4. So B is 2, A is 4. So a lot of you got it right. Good job, that's fantastic. All right, good stuff. I see even some of the lower grades, you know, that's the fun thing about puzzles. It's all about the way you think about things. Doesn't matter what grade you're in. Okay, so someone wanted another example of the previous question. So let's go for one more example. Let's say h of x is equal to x squared and g of x is equal to 1 over x. What we're going to do is we're going to find the value of g of h of 3. Okay, so that's what we're going to work with. So we have h of x is x squared, g of x is 1 over x. Now we're trying to find the value of g of h of 3. So the first thing we're going to do, like I told you earlier, we're going to look inside the parentheses. Whenever you look at order of operations, it applies to so many things. So we're looking at PEMDAS, so let's look inside the parentheses. Inside of this major parenthesis, I have h of 3. Okay, so that's what I'm going to focus on first. So h of 3 is going to be 3 squared. 3 squared is equal to 9. Now that I have h of 3 is equal to 9, so I now have g of 9. So now I'm going to apply that here. So g of 9 is simply 1 over 9. So that's it. So there are lots of more complicated type of ways of asking this question, but for the sake of this session, I will stop right here. This is about where we can go. But if you want me to go into further detail with this topic, you go to the link that has been posted in the chat. Go there and let me know that you want that, or if you have questions along these lines that you're not sure how to solve, go there and also post it so that next week when we meet, we can also walk through it together. So the topic is composition of functions or composing functions. Let me just write it here. Composing functions. Or we can call it composition of functions. Depends on how you want to call it. Composition of functions. Okay. All right, let's go to our next question. In the next question, we're going to be looking at radical equations. We're going to be looking at radical equations. This is a big Algebra 1 topic. It's also quite important in the Algebra 2 class. So we're looking at the solving radical equations. In this case, we want to find the value of x, where the square root of x squared minus 9 equal to 4. The square root of x squared minus 9 equal to 4. We need to find, remember, anytime you're working through equations, you're trying to isolate a variable. So in this case, we're trying to isolate for x. So we're going to isolate the x variable, and once you isolate that, you should get your answer. So give it a shot and let's see if you have any questions. If you've never seen this before, you're not sure what to do with radicals, let me know, and we'll be glad to assist you with that. Also, if you look in the chat, there's a link there to a video that focuses on composing functions and composition of functions. So you can go there as well for additional help, additional resources, and additional examples. Okay, I see x equal to 13. So something else I want you guys to feel free to do is, if there's a topic that you are not sure how, maybe you went to our channel and you have not seen that topic, you can also post that in that link. Let us know that you want a video created on a specific topic. We'll be glad to do that. So a lot of what we cover, we have videos already on the channel, and that's why if you subscribe to our channel, you will know when we upload any new topics. We uploaded a few topics already this week. So if you were a subscriber, you would have seen them. And so I see some answers are coming through already. X squared equal to 13. Okay. X equal to 13. All right. So thank you for trying. I always like it when you try. We'll get to solving it together. Let me go ahead and write the question so that we can get to it once we get a few more responses, or once we get people telling us that they're not sure what to do, and then we can just walk through it together. Okay, we have x squared minus 9. The square root of x squared minus 9 equal to 4. So are we ready to solve this together? Or is anyone still trying to answer it? Okay, so both sides. Okay, so here we have a radical. Okay, all right, square both sides. That's a very good point. So we have a radical. Whenever you don't have a number here, you can assume that it's a square root. And so what we need to do, we cannot do anything with this number under the square root, this term under the square root sign. We can't do anything. We need to get rid of the square root symbol. We need to get rid of it. The only way to do it is to square that side. And remember, I told you a few minutes ago that because you have this equation right here, whatever you do on the left-hand side, we have this equal to sign. Whenever you do on the left-hand side, you must also do on the right-hand side. So that's the first step. So let's write that here. Square both sides. Square both sides. And then the second thing you're going to do is solve for x. Very simple. Solve for x. Once you understand the method, it's pretty simple. So you have x squared minus 9 equal to 4 squared. So now that we have squared the left-hand side, what does that give us? It helps us. Squaring this side actually helps us remove this square root sign. So we now have x squared minus 9, and then 4 squared is 16. So you're going to simplify now. Now that you've done all of this, you can simplify. So we simplify and we're solving for x. So we're going to add 9 to both sides. Let's add 9 to both sides. And we have x squared equal to 25. So x squared is 25. Now we need to find the value of x. We're going to do the opposite. In order to isolate, this is an important tip. Whenever you are isolating for a variable, you're going to do the opposite of what is currently happening to the variable. So right now the variable is squared. So the opposite operation of that is square root. So we're going to find the square root of x squared to get x, and because of this equal symbol, we're going to also do that right here. So x equal to 5, very true, but it's not complete. Here's what you need to remember. So x, whenever you have a square root, you can have a positive value and also a negative value. So this is going to be x equal to plus or minus 5. So here x equal to plus 5. We also have negative 5. So now what we're going to do, because sometimes we have something called extraneous values, which means we get them by solving the equation, but when we put it back in the equation, it doesn't make a lot of sense to have that value. So we're going to test. So here we're going to have square root of 5 squared minus 9 is going to give us square root of 25 minus 9, which is 16, so which is going to give us 4. So this value is a good value. The next thing we're going to do is the square root of negative 5 squared minus 9. This negative 5 squared is 25 minus 9. You're also going to get 16, which is going to give us square root of 16 is going to give us 4. So therefore, what we have here is x equal to negative 5 and positive 5. So these two values are valid for that equation. Does that make sense to everyone? Looks better? Everyone feeling good about it? Okay, let's see, what are we going to do next? We're actually going to do work, a word problem on work. Let's do that. Okay, let's do a word problem on work. So this is grade 8. Sometimes you may see it in Algebra 1, depends on how the teacher looks at it, but a lot of times this is a grade 8 type of question. So Brian can mow his yard in 2 hours. Michael mows the same yard in 3 hours. How long will it take for them to mow the yard if they work together? How long will it take for them to mow the yard if they work together? The same yard. So we're looking at the same work, the same amount of work that is going to require. How long will it take for them to mow the yard if they work together? So I'll give you a hint here. I want you to think of unit rate, or some may call it unit work in this case, or unit rate of work. So I want you to think about that. That's very important for you to answer this question. This is a very common SAT question. I've seen it so many times. It's a very common type of SAT question. So I want you, for those that are thinking of the SAT and even the ACT, if you're looking at any of these tests, these are the kind of questions that sometimes come through in those tests. For those in SAT, this is going to be on the test where you're allowed to use a calculator, but I'll show you how to do it without having to use a calculator. So if you're not sure what to do, feel free to say you're not sure, but regardless, I'm going to walk you through every single step for each of these, for this question. No idea. Okay, that's fine. I'm sure that's why we're all here. We're going to learn together. And after today's session, at least when you see a question like this, you have an idea of what to do. And don't worry, once we're done with this session, I'm going to upload this video. It'll be available for you to take a look at as many times as you need to. Say 1.5, I see 5.1. How did you come up with 1.5? Let's see, 3 divided by 2. 1 hour, 30 minutes. Okay. All right, let's go ahead and walk through this together so I can show you there's some tricks here. Remember I said unit rate of work. Okay, so Brian can mow his yard in 2 hours. So we're going to say that it's 1 yard. Okay, he can mow 1 yard in 2 hours. So we're going to focus on how much work each of them can do in 1 hour. Okay, we're going to focus on how much work each of them can do in 1 hour, because we need to figure out how much work they can do in the same time. Okay, so Brian if he can mow 1 yard in 2 hours, in 1 hour, so we're going to, because here we're dividing by 2, so we're going to see that he can mow half his yard in an hour. So that's the first thing we're going to do. We're going to look for unit rate of work. How much work can be done in 1 unit of time? In this case, it's hour. Now for the second person, Michael, he mows the same 1 yard in 3 hours. So we need to figure out how much of that yard he can mow in 1 hour. So we're going to simply say that we're going to divide this by 3 because we want to find out how much work can be done in an hour. So we divide by 3. Also, we divide this by 3. So now we have a common way of measuring the work that they do. So what is that common way? So let's see, it's Brian half of his yard in 1 hour. And then for Michael, he can mow 1/3 of his yard, of that same yard, in 1 hour. Okay, so now the question needs to be, how much work can they both do together in 1 hour? Okay, how much work can they both do together in 1 hour? That's when you add all their individual works together. So in 1 hour, Brian and Michael can mow 1/2 plus 1/3 of the yard working together. So 1/2 plus 1/3, this is going to give us, let's remember our bow tie method, 1/2 plus 1/3. So let's do a bow tie method. Let's multiply this way, multiply this way, multiply across. So 3 multiplied by 1 is 3, 2 multiplied by 1 is 2, and then we have 2 multiplied by 3, we have 6. So this is 5/6. So in 1 hour, so let's look at it this way. In 1 hour, so the next step we're going to do here is, let me see. So the next step we're going to do here is we have 5/6 divided by 5/6. That is going to give us x, and then we have 1 divided by 5/6 is equal to x. We're now going to change this to 1/1, change this to a multiplication, and then we have 6/5. This is going to give us x. So 6/5 is going to give us x. So what does 6/5 represent? It represents the amount of time. So we can say 6/5 of an hour, 6/5 hours, is how much is going to require to mow that yard if they work together. So you can simply say this is 1.2 as well, or you can say it's 1/5. All depends on the way the answer is presented is going to be your answer. So both of them working together will mow the yard in 1.2 hours, in 72 minutes, or 1.2 hours, or 1/1/5 hours. So this is how you solve this type of question. I don't know if I have the videos on this one yet. This is a topic I may not have done yet, but if you guys, I will actually go create some videos on this topic, because I know this is so important, especially as you go higher in your math learning. We're going to do some on mixtures and some on rate of work. That's very important. So I'll try to work on that. You will only know when I'm done if you subscribe. So go ahead and subscribe. If there aren't, remember, there's a link on the chat. If you want more topics that are important to you and you want me to make videos on them, go ahead in that link and post that information, and I'll be glad to do that for you. Also, let's go for our last puzzle. I had some other questions, but it's better for me knowing that the topics that we've addressed are topics that you care about. So there are other topics, and we can do them next week. And so, okay, thank you. Thank you for the subscription. And so we're going to go do our last puzzle for the day. This one is going to be fun. So we want to find the missing number in the puzzle. Let me give you a hint. I'm going to give you a simple hint here. You're going to need the number 3. You need the number 3. Okay, I see, Satish. If you go to that link, we'll post that link again. If you go to that link and post that, next time we will do some questions on coordinates. Let's go ahead and finish up this puzzle. Let's see if you're going to need the number 3 for this puzzle. Okay, let's see if anyone else has an answer, and then we can get this going. One equal to 4 minus 3, okay. And so the answer, someone says 1, okay. You're going to need exponent as well. Let's give you the next hint. You need exponents. You're going to need exponents. Let me help you with the first one so that it'll give you 2 minus 1 equal to 1. Put as 11, 1 plus 4, 1 equal to 4, so 4 equal to 1. Okay, 3 minus 3 is 0, put together is 30. Oh, okay. All right. Let's see what happens to the last one. Okay, you all are thinking, that's all that matters. So let me give you a hint on this one. 3 to the power of 0 plus 0 equal to 1. That's the hint you need. 3 to the power of 0. So remember I said you need number 3 and you need exponents. 3 to the power of 0 is 1. 1 plus 0 is equal to 1. So that's your hint right there. If you follow that through, you should get your answer at the bottom. Yeah, you guys are thinking good. Guys, that's one thing I enjoy about these sessions. I get to learn how students think through problems, and also informs the way I create videos. When I see how students think through things, then I can also make sure to account for that, to warn against things that I think may be the wrong way to do it, and also to encourage a method that I see that may be the right way to do it. Okay, so let's see. Who's done? Who has an answer? Great, great. Class 11, great. Fantastic. Thank you for joining us from India. Thank you. Okay, let's go to the next one. The next one is 3 to the power of 1 plus 1 is going to be 3 plus 1, which is 4. Right after that, we have 3 to the power of 2 plus 2. 9 plus 2, we have 11. Then we have 3 to the power of 3 plus 3. You can see that this is the exponent. This right here is the exponent, right? All of these numbers here will be your exponents, and also the number you add at the end. Oh, you're very close, Esther. Very close. Very close. Adeza, you're also very close. So 3 to the power of 3 is 27 plus 3, that is 30. Now 3 to the power of 4 is 81, and we're going to add 4 to that. It's going to give us 85. All right, so that's what we have. So thank you all for your time, and I really appreciate. I've actually enjoyed myself today. I enjoy your participation. I appreciate you all participating in this session. Thank you, and feel free to subscribe. Also, share this with somebody. Let someone know that this is an available resource for them. And look forward to hanging out with you again next week. Make sure you enjoy your weekend. Stay safe out there and remain blessed. Thank you all for your time again. Bye for now. Okay, good night. Good night to those in India. For those in the United States, good afternoon. Enjoy the rest of your day. Thank you. Bye.
Hi, my name is Arifa Adelacimo, and I'm making this video today to tell you about a wonderful opportunity you have to invest in yourself and your own future career goals by enrolling in Matthews Tutors. I'm currently a freshman student at Columbia University in the city of New York, an Ivy League institution, where I am studying neuroscience and behavior on the pre-med track. I personally don't believe that I would have had the ability to call myself a Columbia student had it not been for the efforts of Matthews Tutors all those years ago. When I was in high school, I struggled with math, and I knew that I struggled with math. Math filled me with fear, and I wasn't confident doing it. But after just a few sessions with Matthew's tutors, not only was I instilled with the confidence to go forth in whatever math classes I chose to take, but I was able to increase my ACT score by almost 10 points, helping me earn a super score of 35. With those numbers, I was able to get accepted to all 16 colleges I applied to, including, but not limited to, Cornell University, Georgetown University, Tulane University, Duke University, and the college I currently attend, Columbia University. Matthews Tutors is going to do everything that they can to help you. That's what they did for me. But not only are they going to help you be a better student, they're going to continuously check in on you. I know that I personally received a lot of messages of support from them during my first semester of college, which was one of the hardest semesters I've ever experienced as a student. Matthews made sure that I had the confidence to go forth and pursue my own academic goals, but they also helped me increase the numbers too so that I could get where I wanted to be. And I know that they can do the same thing for you if you give them a chance. Thank you.